Okay, hi there, I'm Hao, and it is just another video of me solving random numerical problem. So we need to find the distance um, in a binary tree, right? So we are given what? We are given two numbers, right? Which is two node value here, and then we need to find the distance between them, right? So 5 and 0, right? 1, 2, 3. The distance gonna be the number of edges, number of edges here. On the path to the tree. So 5 and 0 is 3. 1, 2, and 3. Right. 5 and 7 going to be 2, 1, and 2. Right. And the last one is 5 and 5, right? Which is going to be 0 because there's no edge. Right. Okay. So how are we going to do this? So let's assume that um we know the least common ancestor. So the lowest the lowest common ancestor, the LCA, right? Lowest we're gonna start. Let's say we're gonna start from the lowest common ancestor. Right? So what does it mean? It means that okay, so between node 5 and 0, right? Node 5 and 0, what is the lowest common ancestor? So what is the lowest common parent between uh the two nodes, right? So which is the parent gonna be node 3, right? Which is the LCA. We're gonna start from here, right? And we're gonna start the distance from 0, right? And we're gonna go level by level, right? So doesn't matter where the LCA start, right? Where we start, we're gonna count it at level 0. Right? So in this case, coincidentally, it is at the first node, right? So here, so we just have to iterate level by level, right? And if we found the node, we're gonna so okay. So when do we stop? We stop when we're running out of the number of nodes, right? Because we are doing it level by level, so we need a queue, right? A queue to store the nodes. So we will stop when the queue is empty, or when we found both nodes, right? Right. So let's say we can have two flags. P foul equal to false, right? And then Q foul equal to false, right? We will stop when we foul both nodes. Okay. So we will start from the lowest common ancestor and then go from there. Okay. So level 1, right? Sorry, level 0 first, right? Level 0 is only one node, so we couldn't find so P in this case is 5 and then Q is 0, right? We cannot find P or Q on level 0, so we go to the next level. So now it's level 1. Okay, so on level 1 we found P, right? We found P, so P is 5. We found P. We found P. So let me change color here. We found P, right? So this is gonna become true, right? True. P is 5, right? And when we found P, we need to add the level to the distance. So this become 1. Okay. So we stop when P and Q are both found, but no, only one is found. So we have to keep going, right? Okay. Next level is level 2. Right? Okay. So in this level, we found Q, which is 0 here, right here, right? So we set this to true, of course, true, right? And then we need to add the level to the distance. So this becomes 2. Okay. Now P and Q are both found. We return the distance. Okay. We get exactly 3H here. 1, 2, and 3. Okay. Uh let's look at another example. Let's look at another example. So that we can understand this thoroughly. Okay. So in this case, distance is something out 0, level is 0. What is P? P is 5, Q is 7. Okay. So 5 and 7. Okay. In this case, what is the LCA? What is the lowest common ancestor? The lowest common ancestor gonna be 5, right? It is the LCA. Okay. So we start out from level 0, right? So where the lowest common ancestor located will be our level 0. So we're gonna start from there, right? So yeah, we're gonna start from there. Okay. So we found P, right at the top, right? So we set P to true, right? And then we add the level to the distance. So in this case, 0 plus 0 is still 0, right? So we don't care. Okay. Now we go to the next level, level 1. The 1, at this level, we cannot found Q, right? So we go to the next level. So this become level 2. In this level, we found Q. So this becomes true, and we need to add the level to the distance. So 2. So we return 2, right? Which is correct here, 2H. Okay. Right. And in the last example, P and Q are both 5, right? So we found P and Q right at the top. So it's gonna be 0. Okay. So you see how this works. If we know the lowest common ancestor of the two nodes and we start from there, we will be able to find the distance between the two nodes, right? So, but how do we find the lowest common ancestor? So let's just code this part up first, right? Let's assume we already know the LCA. Right? We're gonna have some kind of function to find the LCA, right? Okay, so this is gonna be our helper function, LCA, right? Passing in the node, right? We're gonna do something to find the LCA, right? But after we found the LCA, we're gonna add it to our queue, new my queue. So this is my custom queue. In JavaScript, feel free to use a built-in one if the language of your choice has it. Okay, so we wanna add it to our queue or push LCA. So this is the LCA node. Right? So we're gonna have our level starting out at 0 always. Right, our distance is also starting out at 0. Level distance. What else? We need the two flag. Remember, p file and p file is false, right? And then q file is false. So this is gonna be let because we want to be able to update it. Okay. So as I said earlier, when we start when the queue is empty, right? Right. Or when both node is found. Okay. P file or queue file, right? So in other words, if the P is not found, which is false, right? So this whole phrase will return true, right? So as long as one of them is not found, we will keep going, right? It will stop when both of them is found, right? So if both of them are found, uh, false or false, right? This whole phrase will return false, and we will stop, right? But otherwise, we need to keep going. Okay, so we need to go level by level. So we need to keep track of size, queue dot length, of course. Okay, so the node equal to queue dot pop. So if the node, right, if this node is equal to p, then we need to set p file to true. Remember, and then we need to add the level to this thing, right? right? Remember we need to do it for Q as well, right? On the same place, because like in this case, right? P and Q are both 5, then we just gonna return 0, right? Because the level start out at 0, right? So this one is going to be Q. So if node of value equal to Q, we set Q path to true and then add that to the distance, as the level to the distance, right? And then we need to add the child, of course. We are going level by level here. Okay. And then lastly, we need to increment the level, right, as we go. In the end, we will return the distance. Okay. So assuming we already know the LCA, we're gonna start out at the LCA, the lowest common ancestor node, right? Um, yeah, we're just gonna go through every single node on the current level, right? And then to see if we can file P and Q. If we found it, we add the level to the distance, right? And then return the distance at the end. We, of course, we're gonna add the child and update the level every time. Okay, we stop when we found both P and Q. All the Q is empty. Okay, so the only problem we have left now is how do we find the lowest common ancestor or the LCA? So how do we find the LCA? Right. Okay. So to find the LCA, we're just gonna use DFS to find the LCA. Right. Um. So assuming, let's say we start from the tree, right? We're gonna search from the left and the right. To see, and then if we found the most node on the left and the right, right? In that case, we will return this node, right? So in other words, if we found P and Q on the left and P on the left and Q on the right, or vice versa, um, we, the current node will be the lowest common ancestor. Okay, so we will stop when in three case, right? Stop when the node is null, right? Node is null. The second case is when node dot val is equal to P. Right? The third case is when node dot val is equal to Q. Okay. So we're gonna do DFS, right? We're gonna go all the way to the left. And here, the node is null, so we will return back up. So what do we return? Um, if we have both left and right, we will return the node, right? If we have both left and right, which means the current node. So if the left, right, return the node and the right return the node, right, which means we found P and Q. So which means that the current node here, right, will be the LCA. Okay. And if not, we're just gonna return no backup. Right. So in this case, let's see. In this case, we have no, right? No on the left and no on the right, right? So we will just return no backup, return no. Oh yes, sorry. Let's do it again. I forgot to keep track of P and Q. Okay, so P is 5, P is 5, and then Q is 0, right? So okay, so as we go to the left here, we found P, right? If P is 5, so we're gonna return 5 backup. Okay, so we go to the right, 1, keep going, depth first search, right? So 0, so we found 0, so we return 0 backup, right? Return 0 backup. This is 5, return. This is 0, not 0, return backup. and then we go to the right. So right, left and right gonna return no, right? So we're just gonna return no backup, right? So now, at node one here, what do we return backup? Because we found zero, right, on the left, right? So we're gonna return the left backup, right? So we keep returning zero back to the top because we found zero in this branch, right? Zero. Okay. So now we are returned back up to node three. Right? And on the left branch, we have a node, and on the right branch, we have a node. So which means three gonna be the LCM. Okay. So let's look at another example here. Example two. Let's say P is 5 and then Q is 7. Right. So 5 here, we found 5, right? So we return 5 back up. Right. So this gonna return no, right? This gonna return no backup, right? So no and no, so this gonna be no. Right. Right. So 5 and no, because we have 5 and no. So in the previous case, right? We have 5 and 0 are returning back up to the root, right? Which means the current node. So if we have both node, which means the current node here gonna be the LCA, right? But in this case, we only have one side, one node, right? Which means this node gonna be the LCA, the left branch. Right? Okay, so that is how we file the LCA. Okay, so if the node is null, right, or node of val is equal to P, or node of val is equal to Q, you return the node. Otherwise, we need to do the DFS, looking at the left and the right. LCA, node the left, right, cons right equal to LCA, node the right. It's gonna be equal. Okay, and then if we have both left and right, right. So if we found the left on one branch and the right on one branch, the current node gonna be the LCA. Return node, right? Else we're gonna return the left. If we have left, we return left. Otherwise, we return the right. And it worked. Thank you for watching.